Hello, everyone, and welcome to ROKStudios. I'm Stan Miller. I'm PR and Analyst Relations Manager for Rockwell Automation in the EMEA region. And I'm joined today by Nicola Iovine, Strategic Business Developer for Rockwell Automation in EMEA. Nicola, welcome to the studio again.
Thank you so much. Thank you for inviting me.
So, Nicola, today we're here to talk about simulating the future and how AI-driven digital twins are transforming industrial automation, artificial intelligence being such an incredibly important and hot topic right now. Can't wait to get your insights and information on this topic, so let's just get started.
Yes, let's get started.
All right. To begin, from your perspective, what strategic advantages do factory-scale virtual controls testing and high-fidelity simulation offer manufacturers in terms of commissioning resilience and operational efficiency?
Yeah, definitely. Look, factories are very complex environment. So you have thousands of moving parts, you have high-speed machine, process, robotics, logistics, and there is a lot of difficult or complex system interactions. So manufacturers see the need for having a scalable and a high-fidelity digital twins to basically accelerate commissioning times and optimize their system performances. So what we have seen in the recent years is that they were running virtual controls testing of like a piece of plant or a special machine or some critical line, but now they see the need of having a full-scale factory digital twin where they can test and validate and combine the mechanical, the electrical, the robotics, the process part, all in one unified digital twin model. And virtual controls testing is going to help manufacturer in reducing their commissioning time and costs because they are able to test and validate everything herely and virtually. But also, it's going to improve their operational resilience because they are able to detect issues just earlier before they will happen, right, in real life. And finally, they can improve their operational efficiency. They can boost it, basically, by optimizing their processes and the resources they use.
Fascinating what can be achieved at this point virtually. Nicola, as digital twin technology becomes more advanced, what skills and workforce will engineering teams need to help adopt and fully leverage tools like these AI-driven simulations that you're talking about?
Yeah, definitely. As the digital twin technology evolves, the engineering teams need to combine the traditional expertise, which is about automation, mechatronics, with different skills like data analysis, like AI, programming. And this is key. This is key because actually it requires also an effective collaboration between different disciplines, like different departments, like engineering, IT, and data science. And so they should be able to build a high accuracy simulation models to analyze big data, basically to foster their design optimization. So, and what we are seeing is also that the engineering workflow is changing because currently, I will say in the past, we have a sequential workflow where you have different phases, very well defined. One is over, the other one starts. So you have design, manufacturing, test, validating, and production. And now, because the AI models are seamlessly integrated in this engineering workflow, you see that the engineering teams need to be more agile to adopt new technologies, but also the engineering workflow is becoming iterative because now you have the AI models that you need to test, validate, but also train as well. So this is what I see in terms of changes in the engineering teams.
That's fascinating evolution. Nicola, how do you see AI-driven simulation and digital twins shaping the future of autonomous operations and decision-making in smart factories?
Yeah, that's another great question. So AI-driven simulation and digital twins, I think, is key to enable autonomous operation in smart factories because this will allow customers and manufacturers to optimize their production, to run predictive maintenance while they are implementing AI models. And so AI-driven simulation is is really critical, because a lot of customers are looking into way on how they can leverage this AI technology to improve the performances, to improve their efficiency, and they set a target, right? So now, I mean, if you implement into the real production immediately without testing, eventually you may get like a result that are far from what you were expecting. But instead, what you want to do is, okay, I have my AI model, I can test, verify, I can train this AI model in the digital twin world, so into the simulation world, and make sure that I can achieve the outcome and the results I'm looking for. And then after that, I can simply implement into the real production, and basically I get what I was looking for. So that's why I think it's really important, and it's really critical to shape the future of autonomous operation in smart factory using AI models and AI-driven simulation.
It's a great example of how AI is this enabling technology, and it's really fascinating to see how it applies to digital twins and in the virtual world. Nicola, thank you so much for joining us in the studio today. Always a pleasure.
Thank you, Stan. It's my pleasure.
And thank you for watching. If you'd like to learn more about industrial automation and digital transformation, visit rockwellautomation.com.